Chapter 4, Evaluating Choices, Time, Risk, and Value. There are a number of key terms in this chapter that I want to make sure we understand before we go through the content. The first is liquidity. So this is how easily assets can be converted into cash, because cash is the most liquid asset. Now, the more liquid an asset is, the better, because that means you can use that money today on something. In general, transforming something that's not very liquid into liquid wealth or cash will create a transaction cost, opportunity costs, and risk, all of which take away from the value of your wealth. So liquidity, or cash, has value because it can be used without any additional costs. The next concept is cash flows. So this is how cash comes in and out of an entity, that entity being you. Now, cash flows in the past are sunk, and we learned about that in a previous chapter, and cash flows in the present are liquid, whereas cash flows in the future are not yet liquid. We haven't gotten there yet, right? So you can only make choices or decisions with your liquid wealth, not with cash that you don't have yet or that you've already spent up. This leads us to the concept of opportunity cost, which we also previously learned. So this is more of a reminder. Opportunity cost is the cost of sacrificing your next best choice. Ideally, you want the benefits of your decision to be greater or outweigh the opportunity cost of your second best choice. And then there's risk. And so there's always some uncertainty about the future because you don't know whether or not you're going to actually get your cash flows and how much they'll be worth when you do. But what you do know in the moment right now is any liquid wealth that you have, that's right in front of you. You can use it. Whereas if you took that cash right in front of you and put it into something for the future, you don't know exactly what the outcome will be. Some more key terms that we're going to be using for the math calculations in this chapter. The first is the present value. So that's the value an item has today if it were liquid. Whereas future value is the value an item has in the future, based on an assumed rate of growth. So when dealing with future values, we have to make an assumption on what that rate is going to be. And so that discount rate, or R, is the rate at which time affects or discounts money. It's the opportunity cost of not having liquidity because you're waiting for it over time. So term, or T, is the length or time of an investment or commitment. So putting all of these terms together leads us to the concept of the time value of money. That's the idea that a sum of money is worth more now than the sum of money will be at a future date due to its earnings potential in the interim. Because the further in the future cash flows are, the farther away you are from your liquidity, meaning the more opportunity costs and risk you have, and the more that takes away from the present value of your wealth, which is not yet liquid. So time puts distance between you and your liquidity, and that creates costs that take away from value. So the more time there is, the larger its effect on the value of wealth. So for example, if I gave you $100 today, you could take that $100 and invest it in something to earn money. Whereas if you had to wait and I said, you know what, I'm going to pay you $100 next year, and then next year rolls around and I hand you that $100, you've just missed out on the potential earnings that you could have had if I gave you the $100 today. So that's the difference between $100 today versus a year from now. So let's go ahead and calculate the relationship of time and value. So to do the math, we need to know what the future cash flows will be, when the future cash flows will be, and the rate at which time affects value. So here's our scenario that we're going to work through. What is the present value of $1,000 received 1 year from now if invested at 7%? In other words, you want to ask yourself, how much do I have to invest today to receive $1,000 in the future, specifically 1 year? So in our textbook, it offers this formula here, the present value times 1 plus our discount rate, exponent T for time. That's going to give us our future value. So I do have the question here just to kind of recap what it is we're working with. But what I've done is I've rearranged the formula just for us to more easily understand. You can see I've taken this part of the formula and divided it by both sides, which will allow me to move this over to the right and isolate the present value on the left. In other words, we want to find the present value by taking our future value and dividing it by 1 plus the discount rate to the exponent of however many periods we're working with, or the years. So when I plug in all my numbers, there's my $1,000 or my future value on the top that I'm expecting to receive. Then my 1 plus the 0.07, because that's how I write 7% as a decimal. And then the 1 here is because the 1 year that is in the future. And when I plug all that in, I get $934.58. Now, another way to do this calculation is to use a table. So I've got a table here on the right, and in this table, it'll give us our present value factors for that lump sum we're working with. So you'll take the 7%, you'll look for the column that has the 7%, and you see that right here. And over on the right, and again, depending on the setup of the table, sometimes the periods is on the right side or the left side, so just look at the side. You can see here the periods of how many years. We're working with 1 year, so I'm going to use this 1 year row and look down the 7% column, and my present value factor is 0.93458. So taking that over here, and I can, it's 5 decimal places. Maybe I want to round it, clean it up a little bit. So I'm going to go ahead and round my 8 makes my 5 go up to 6. So I'll take the $1,000 I am expecting to receive a year from now and multiply that by my present value factor of 0.9346. That gives me a present value of $934.60, which is very similar to the present value if we were to calculate it using the formula up here. So either way, if you want to use the formula or if you want to use the table, you can. And again, let's recap what this means. What this means is I would need to invest $934.60 today in order to get $1,000 a year from now, assuming that that investment is at 7%. So in a year, I would have earned about $65. That's the change in the money between today and a year from now. Let's look at another example. Like, what if we change the question a bit? Instead, what's the future value of $1,000 invested today? That's my present value. 5 years from now, if invested at 7%. So again, I'm taking my formula here and I'm going to just kind of rearrange it just for easy reading. Again, I want to find out the future value. If my present value of $1,000 that I invest today times 1 plus my discount rate, that's the 7%, so it's still 1 plus 0.07, and then 5 years from now. So I'm changing the number of periods. It's 5 years into the future. So I'll do exponent 5. And when I plug all of this into my calculator, I get $1,402.55. In other words, if I invest $1,000 today and let it sit for 5 years at a discount rate of 7%, I will have earned a little over $400. Now, again, if you prefer to use the table, this is a different table. This is the future value table for a lump sum. And again, I'm going to take my amount deposited today, that's the $1,000, and multiply it by the future value factor from the table. So I'm looking at the 7% column. And since we're working with 5 years, when I look over here on the side for periods, I'll go until I find the 5 years row, and then move across that row until I get to the 7% column, and that's the 1.40255 is my factor. So again, I'll set up my calculation. I'm just multiplying, and I'm going to clean up the rounding a little bit just to make it pretty. So I'll go ahead and round it up. As you can see, 5 rounds up to this 5 to the 6. And then when I multiply that, I get $1,402.60. Again, whether you're using the table or you're using the formula in full, they're very close to each other, very similar answers. And again, this will let me know what that investment would potentially earn in the future in 5 years. So a little over $400. So that's how we find the future value of something. So as you're working on this week's homework problems, you'll see at the top of the assignment, I do have a video tutorial that will explain how to use the time value of money tables. And then you can see I have the links to the actual tables here. There are 4 different kinds depending on the scenario. So make sure to watch the video so you understand which one's which. And then just below are the formulas that you would apply those factors to. Now, some more key terms to be aware of. There's compounding, which is how an investment will grow if interest is calculated based on the principal plus the accumulated interest. So the principal is the initial amount, and the accumulated interest, that means interest on interest. So if you're earning interest each year, you're going to continue to earn interest not only on what you originally invested or the principal, but also on anything you earn each year. So it's great. So make sure in this week's reading guides and videos page in Canvas to check out the Investopedia video on compound interest. It'll do a much better explanation with some visuals that will help you understand the value of compound interest. The next concept to know is an annuity. So this is a series of payments at regular intervals and regular amounts. So an example might be receiving $1,000 a year for 10 years. And going back to the homework, you'll also apply those time value of money tables for annuities, for instance. And then there's perpetuity, which just means that it's an annuity that continues forever. So let's look at an example of valuing a series of cash flows. Say you win $10 million and the lottery agency offers you two options. You can either take $500,000 per year over 20 years, or you can take a one-time lump sum payout of $6.7 million. So that $6.7 million, if you got it today as a lump sum, that's your present value. That's the cash they just would give you right then and there, and that's your most liquid option, right? Whereas the $500,000 per year over 20 years is the annuity, the series of payments. It's the same amount every year for 20 years. And so the value of that annuity is not just 10 million. It's not just taking the 500,000 times 20, because those $500,000 payments are received over time, and then time affects liquidity and thus its value. So really what you want to ask then is, what is the annuity worth to you as it relates to the ways that you could potentially invest your money? So what I've got here is the table of present values from the lottery with different discount rates. You can see here in the column left, our cash flows is that $500,000 a year, and we're doing it for 20 years. So these two columns, those variables don't change at all. But the variable that is changing is your discount rate in percent. So for example, this is 6%, this is 12%. It's just written as a decimal. And then that will impact the present value in the far right column over here. And I drew these red lines to just kind of help separate the numbers as we're making our decisions or interpreting the table. So what I want to point out first in this bottom row here is that the annuity would be worth the same to you as the lump sum payout if your discount rate were 4.16%. But I just want you to see that at $500,000 a year for 20 years at 4.16%, your present value is $6.7 million. Then let's look at the middle of the table here, right? So if your discount rate is higher than 4%, so I've got some examples here at 6% up to 14%, or if you feel that you could use that liquidity and earn more than 4% and do better things with it, then the annuity is worth less to you than the payout. And you can see that right here. The present value for these different discount rates is less than the $6.7 million payout. So if you can get a better discount rate, take the payout. And then last but not least, looking at these two rows here, we can see that at 2% and 4%, the present value is higher than the 6.7 payout. It's at like a little over 8 million and a little bit over the payout lump sum. So if you don't have better options than earning 4% with that liquidity, it's better to take the annuity than to take the immediate payout. So let's take a look at the math behind the 4% specifically right here, right? So if I take my present value table, again, you'll see this in the homework. It is one of the options specifically for annuities. Here we've got my 4% column. And over on the right, looking at the periods, I'm going to go down until I find my 20 years. That's how many periods of payments I'm going to get. And moving across that row, the present value factor is 13.59033. So I'll go ahead and take that and multiply it by my 500,000, my cash flow. And that'll give me a present value of $6.795 million, give or take, depending on how you round. So you can see at 4%, it's better to take the annuity because it's more than the lump sum of 6.7 million. Now that we understand time value of money, let's go ahead and talk about pro forma financial statements. And we learned about financial statements in a previous chapter, but this is a slight adjustment to it in that these financial statements project potential future results. So this helps us see the consequences of our choices. Now, to project future financial statements, you need to be able to envision the expected results of all the items on them. And it can be a bit tricky because predictions always contain uncertainty. So these projections you're making, at best, are educated guesses. But they're still useful in helping you see how the future could look. Now, in the chapter, there's an example with Alice's projected cash flows and balance sheets, an income statement, and you can see how whether she, continues to work, gets a second job, or goes to Vegas and wins or loses, there are some different scenarios that you could see and then can compare. But when you look at her pro forma statements, you can see that there are multiple lines of information, as you recall, in our financial statements. And what you're doing is you're projecting what that will look like under different scenarios. And then that way Alice can assess what's her best option. That leads us to evaluating risk. And another way to think about risk, or the negative connotation that we tend to hear or think of when we hear the word risk, is the potential downside of a decision or event. And so the study of risk and the interpretation of probabilities are complex, but having a general understanding will help us make decisions about our financial future. And so one concept you want to make sure you understand is the concept of an independent event. And that's an event that happens by chance. You can't will it or decide what's going to happen. You just got to let chance do its thing. So for instance, if I'm flipping a coin, I know my outcomes are either heads or tails, but I can't make the coin, without cheating anyway, show heads, for instance. So I can't will the coin a certain outcome. I just have to flip the coin and see what happens. Same thing with doing an investment. I can invest in a particular stock, and that event or the outcomes of investing in that stock could be either earning money or losing money on that stock. Again, I can't will it or decide it. But what I can do is do research, and you'll learn about it later in this course, as you can do research on that stock. We can look at its history, its past stock price over the last 6 months, or last year, last 5 years. And so we can measure the probability based on that history and use that to then predict if it will reoccur. Will that stock continue to rise? Will it go up or will it go down according to history? When we are trying to understand what that outcome will look like, that's where we need to calculate the expected value. So the EV, or expected value of an event, is the sum of each possible outcome's probability multiplied by its result. So the formula here that you see, we're going to take the P, or probability of an outcome, by the number of outcomes possible, and multiply it by its result. Again, by the number of outcomes possible. And when I multiply those, I will go ahead and add up or sum all those together to find the expected value. Now, we're not necessarily going to do that in this class, but if you ever take a statistics class, whether AP stats or, for instance, business stats at MiraCosta, you would learn how to calculate the expected value in different situations so that you can make decisions. And so in this class, we make financial decisions. In a business stats class, you would be using these calculations to make business decisions. So what's useful to know about expected value is that it allows you to weigh against or compare the values of other choices. So rather than using emotions or your gut to make a financial decision, you're using a more objective process to calculate the probability of something happening and then making the better choice.